Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. We know that AB is the diameter of this semicircle, and we know that AD equals to 7 units, DC equals to 15 units, and CB equals to 15 units, and we want to find out the size of the diameter of this semicircle that is actually AB. We want to find out the value of AB. So in the first step we will make a construction. We will join together points D and B by a straight line. We join together points D and B by a straight line, and actually the peripheral angle ADB equals to 90 degrees in its size according to rule number 1 that states that peripheral angle resting on the diameter of the circle is equal to 90 degrees. So I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle is equal to 90 degrees. So actually peripheral angle ADB rests on AB, that is the diameter of this semicircle, Therefore, according to rule number 1, it equals to 90 degrees. So angle ADB, that is peripheral angle, equals to 90 degrees. Okay, so we can write here that angle ADB equals to 90 degrees according to rule number 1, because it rests on the diameter of this semicircle, that is AB, therefore it equals to 90 degrees in size. So in the next step we will define the center of this semicircle as point O. So this is point O, that is the diameter, that is the center of this semicircle, and then we will join together points O and C, these 2 points, by a straight line. And then we will also join together points O and D by a straight line. And we will focus on 2 triangles, on triangle ODC, that is the green triangle, and we will also focus on triangle OCB, that is the orange triangle, again we will focus on triangle ODC, that is the green triangle, and triangle OCB, that is the orange triangle. So in those 2 green triangles, we know that side DC of the green triangle equals to side CB of the orange triangle. Both of those 2 sides are equal to 15 units. Okay, so side DC of the green triangle is equal to side CB of the orange triangle. Both of those 2 sides are equal to 15 units. And actually side OD is the radius of this semicircle, because of the fact that it starts from the center of this semicircle, that is to say from point O, and ends at point D, that is a point of the semicircle itself. Therefore it is the radius of this semicircle. We will mark the radius as R, so OD equals to R. and OB is also the radius of this semicircle because of the fact that it starts from the center of the semicircle and ends at point B, that is a point on the semicircle itself. Therefore, it is the radius of this semicircle. So it equals to R. So actually, side OD of the green triangle equals to side OB of the orange triangle. Both of those two sides are equal to the radius of this semicircle, so they are equal to each other. Okay, so OD equals to OB equals to R, the radius of the semicircle. And also OC is a common side. It belongs both to the green triangle, and OC, side OC belongs also to the orange triangle. So OC equals to OC. It is a common side. Again, OC equals to OC. It is a common side. It belongs to both triangles. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle, we proved that the green triangle we proved that the green triangle is congruent to the orange triangle. Okay, so we proved that the green triangle DOC is congruent to triangle COB, that is the orange triangle, according to side rule. Again, the green triangle COB is congruent to the orange triangle COB according to the rule, according to side rule. So when you prove that all the sides of one triangle are equal to all the sides of the other triangle, then you prove that those two triangles congruent to each other according to side rule. And we proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, those two triangles congruent to each other. Okay, and therefore angle OCD of the green triangle, this angle is equal to angle OCB of the orange triangle, So those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so those two angles are equal to each other, and if we define angle OCD as alpha, then angle OCB will be also equal to alpha because those two angles are equal to each other. Okay. So actually angle OCD equals to angle OCB. Both those two angles are defined as alpha. Okay. In the next step, we'll focus on triangle DCB. On this triangle DCB. So, in triangle DCB, side DC of the triangle is equal to side CB of the triangle, and both those two sides are equal to 15 units. Okay, both the two sides of triangle DCB are equal to 15 units, so they are equal to each other. And we have a rule number 2, that states that in front of equal sides, in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually in triangle DCB, those two sides are equal to each other. So in front of this side CB, we have angle BDC, this angle, and in front of this side, in triangle DCB, we have this angle DBC, and according to rule number 2, in front of equal sides, there are equal angles. So those two angles that are located in front of equal sides are also will be equal to each other. So angle DBC, angle BDC, this angle is equal to angle DBC, this angle. Okay, angle BDC equals to angle DBC. Those two angles are equal to each other according to rule number 2. And if we define angle CDB or BDC as theta, then angle DBC also will be equal to theta. Okay? So angle DBC, angle BDC equals to angle DBC. Both those two angles are equal to theta according to our definition. So they are equal to each other according to rule number 2. Okay, in front of equal sides there are equal angles, so those two angles are located in front of equal sides, therefore they are also equal to each other. And if we define one angle as theta, then the other angle will be also equal to theta. Okay, in the next step we will define this point as point E. And we will focus on two triangles, on the green triangle, triangle DEC, and the orange triangle, triangle BEC. Okay. So we will focus on those two triangles, the green triangle, triangle DEC, and the orange triangle, triangle BEC. So those two triangles, side DC of the green triangle is equal to side CB of the orange triangle. Both those two sides are equal to 15 units, and also angle DCE that equals to alpha in the green triangle is equal to angle ECB that also equals to alpha. Again, angle DCE in the green triangle is equals to angle ECB in the orange triangle. Both those two angles are equal to alpha. And also side EC is a common side. Again, side EC is a common side. It belongs to both to the green triangle, and side EC also belongs to the orange triangle. So EC equals to EC. It is a common side. It belongs to both triangles. Okay, side EC equals to side EC because it is a common side. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we proved that those two triangles are congruent to each other according to side angle side rule. So I write it down. The green triangle, triangle DCE is congruent to the orange triangle, to triangle ECB. According to side angle side rule. Okay, so again, the green triangle, triangle DCE is congruent to the orange triangle, triangle ECB according to side angle side rule. And side angle side rule states that if you prove that two sides and the angle included in one triangle are equal to two sides and the angle included in the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. Okay, so those two triangles can go into each other according to side angle side rule. Therefore, angle DEC in the green triangle equals to angle BEC in the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles are also equal to each other. So angle DEC in the green triangle is equal to angle BEC in the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, and again angle DEC in the green triangle is equal to angle BEC in the orange triangle, and if we define angle DEC as x, then angle BEC will be also equal to x because those two angles are equal to each other. Okay, so angle DEC equals to angle BEC, and both those two angles are equal to x according to our definition. Okay, so in the next step we will focus on chord BD. BD, actually in the beginning of the lecture we make the construction. We joined points B and D by a straight line, so BD is a straight line. BD is a straight line. Okay, BD is a straight line according to our construction, and we have a rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. The sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so actually the sum of the angles on the straight line DB is equal to 180 degrees. So angle DEB, according to rule number 3, angle DEB equals to 180 degrees, because of the fact that the sum of the angles on a straight line is equal to 180 degrees. Therefore, according to rule number 3, angle DEB equals to 180 degrees, according to rule number 3. Okay, angle DEB equals to 180 degrees, according to rule number 3, that states that the sum of the angles on a straight line equals to 180 degrees. So this angle DEB, equals to 180 degrees. But what is the size of angle DEB? We can say that the size of angle DEB is also equals to x plus x. X plus x is the size of angle DEB. So from the other side, the size of angle DEB also equals to 2x. Okay, so we got this equality, and from this equality we can deduce that 2x equals to 180 degrees. 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees. Okay, so angle x equals to 90 degrees, so we can substitute x by a right angle. So x is a right angle, so it equals to 90 degrees. And this angle x also equals to 90 degrees. So here we have also a right angle. And in the next step we will focus on OC, called OC. Actually, we made the construction, we connected points O and C by a straight line, so OC is a straight line. Again, OC is a straight line according to our construction. Okay, we connected together points O and C by a straight line. Therefore, OC is a straight line. And again, according to rule number 3, the sum of the angles on the straight line OC also equals to 180 degrees. And if we look on the left side of the straight line OC at point E, according to rule number 3, the sum of the angles on a straight line equals to 180 degrees. So this angle that is 90 degrees, angle CEB equals to 90 degrees, plus angle OEB must be equal to 180 degrees according to rule number 3. Okay, rule number 3. Again, 90 degrees plus angle OEB must be equal to 180 degrees according to rule number 3, because we have here on the straight line CO, we have this angle that equals to 90 degrees plus this angle that is angle OEB must be equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line equals to 180 degrees. Okay, we have this equality that 90 degrees plus the angle OEB equals to 180 degrees, and if we subtract from this equality 90 degrees, we will get that angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. Okay, so angle OEB equals to 90 degrees. Angle OEB, this angle is a right angle. Okay, so around point E we have 3 right angles, 1, 2, 3, and the sum of those 3 right angles is 270 degrees. Okay, we can write down that the sum of 3 right angles around point E is equal to 270 degrees. That is 90 degrees times 3 is equal to 270 degrees. I read again the things that I wrote. The sum of 3 right angles around point E is equal to 270 degrees. Okay, and we will define the fourth angle, angle OED, as angle Y. And we have rule number 4 that states that the sum of the angles around a point is equal to 360 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles around a point is equal to 360 degrees. Okay, and especially the sum of the angles around point E must be equal to 360 degrees according to rule number 4. So what is the sum of the angles around point E? The sum of the angles around point E is actually the sum of the 3 right angles, that is 270 degrees, plus the size of angle Y must be equal to 360 degrees according to rule number 4. Okay, again, the sum of the angles around point E is 360 degrees according to rule number 4. And we know that the sum of the angles of the three right angles is 270 degrees, so 270 degrees plus the size of angle Y must be equal to 360 degrees. Okay, according to rule number 4, the sum of the angles around point E equals to 360 degrees, so the sum of the three right angles, that is 270 degrees, plus the size of the fourth angle, that is Y, must be equal to 360 degrees. So from this equality, we will subtract 270 degrees and we will get that angle Y equals to 360 degrees minus 270 degrees, that is actually 90 degrees. So angle Y equals to 90 degrees in its size. So actually angle Y is a right angle, it equals to 90 degrees in its size. So here angle OED is a right angle. So we actually found out that all the angles around point E are right angles. Okay, so in the next step we'll focus on triangle, the right triangle, triangle ADB. It is a right triangle because this angle equals 90 degrees, and we will also focus on the right triangle OEB. It is a right triangle because this angle OEB, is a right angle. So I will draw these two triangles again. So I draw triangles, the right triangle ADB and the right triangle EOB. So actually those two angles are equal to each other because both of them is equal to 90 degrees. So angle ADB in the big triangle is equal to angle OEB in the small triangle. Both those two angles are equal to 90 degrees in their sides. Okay, and this angle B is a common angle because it belongs to both triangles. It belongs to the small triangle, triangle OEB, and it also belongs to the big triangle, triangle ADB. It is a common angle. So angle B equals to angle B. It's a common angle. and the third pair of angles, angle BAD in the big triangle, also equals to angle BOE in the small triangle. Again, angle BAD, this angle, in the big triangle is equals to angle BOE, in the small triangle, according to third angle theorem. Okay, according to third angle theorem, again, those two angles are equal to each other according to third angle theorem. Third angle theorem states that if you have two triangles that has two equal angles, then the third pair of angles must be also equal in those triangles according to third angle theorem, because the third pair of angles complete the sum of the angles in each triangle to 180 degrees. We know that the sum of the angles in any triangle equals to 180 degrees. And the third angle must complete the sum of the angles in any triangle to 180 degrees, therefore they must equal to each other. Okay? Actually, okay, so we proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, the big triangle, triangle ADB, is similar to the small triangle OEB, according to angle rule. Okay, so the big triangle, triangle ADB, is similar to the small triangle, triangle OEB, according to angle rule. So angle rule states that if you prove that all the angles of one triangle are equal to all the angles of another triangle, then those two triangles are similar to each other according to angle rule. Okay, so from this similarity between those two triangles, the following relationship exists between the sides of those two similar triangles. The relationship is that OB, the side of the small triangle OB, over the side of the big triangle AB, equals to OE, is the side of the small triangle, over AD is the side of the big triangle. And again, the relationship that exists between those two similar triangles is OB over AB equals to OE over AD. Okay, but what is the value of OB? The value of OB is R. What is the value of AB? AB is the diameter of the semicircle, and we know that the diameter is equal to 2 times the radius, so AB is 2R. It equals to OE over AD. What is the size of AD? AD equals to 7 units, according to what is given us in the question. So in total we got that R over 2R equals to OE over 7. R over R is 1, so R is cancelled. So we got that 1 over 2 1 over 2 equals to OE over 7. One over 2 equals to OE over 7. Here we'll multiply this equality by 7 in order to get the value of OE. So OE will be equal to 7 over 2 units. So OE equals to 7 over 2 units. And what is the size of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. OC minus OE. Okay? From the drawing we can see that EC equals to OC minus OE. Okay? EC equals to OC minus OE. But what is the value of OC? OC is the radius of this semicircle, so it is equal to R minus OE. OE equals to 7 over 2. So in total, we got that EC equals to R minus 7 over 2. EC equals to R minus 7 over 2 units. So in the next step we'll focus on two right triangles. Triangle EBC, this triangle is a right triangle because of the fact that angle CEB is a right angle. And triangle OEB is also a right triangle because of the fact that angle OEB is a right angle. So we will focus on those two right triangles in the orange color. And we also know that EB is a common side. It belongs both to the triangle EBC, and EB also belongs to triangle OEB. So we will implement the Pythagoras theorem on those both right triangles. We will create the statement that states that EB square equals to EB square. Okay. EB square equals to EB square. And we will implement the Pythagorean theorem in these two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So first EB square will be related to this triangle. Here EB square will be equal to OB square minus OE square. OB square minus OE square is equal to EB square. And the second EB square will be related to this right triangle. Here EB square in relation to this right triangle equals to CB square minus EC square. CB square minus EC square equals to EB square. So in total we got that OB square minus OE square equals to CB square minus EC square. So OB equals to the radius, so OB square equals to R square minus OE. The value of OE is 7 over 2, so OE square is 7 over 2 square, that is actually 49 over 4 equals to CB square. CB equals to 15, so CB square is 15 square. 15 square is 225 minus EC square. EC equals to R minus 7 over 2, so EC square will be equal to R minus 7 over 2 square. So in total we got that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square. So here we will open the brackets and we will get that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square is R square plus 7 over 2 square is 49 over 4 minus 2 times R times 7 over 2. Okay, so here we have 2 over 2 is 1, so in total we have here 7R. So we will open the brackets in this side of the equality and we will get that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4. Here we have minus 7R, minus minus is plus, so 7R. So in total we got that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4. So here minus 49 over 4 we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 in the other side of the equality, so we cancel minus 49 over 4, and then we will add to this equality r squared. We will get that r squared plus r squared is 2r squared equals to 225 plus 7r. So we got that 2r squared equals to 225 plus 7r. So here we will subtract 225 and those 7r from this equality, and we will get that 2r squared minus 7r minus 225 equals to 0. So we actually arrived to this quadratic equation, and actually the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we can find out the value of x according to the special formula that states that x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, we will find out the value of x according to this special formula for x. So in our specific quadratic equation, the variable that we want to find out is r, so x equals to r, and the value of a is 2, the value of b is minus 7, and the value of c is minus 225. Okay, so we have all the variables of this formula. The only thing that is left is to substitute the variables that we found in the variables of this formula, and we will get that x equals to r, so r equals to minus b, b equals to minus 7, so minus b is minus 7, that is plus 7, plus minus root of b squared, b equals to minus 7, so b squared is minus 7 squared, that is 49, minus 4 times a, 4 times a is 4 times 2, so it is minus 8, times c, c equals to minus 225, so it is times minus 225, over 2a, a equals to 2, so 2 times 2 is 4. So in total, we got that r equals to this expression. So r equals to 7 plus minus root of 49, and then we have minus 8 times minus 225 is 1800 over 4. Okay, so got this equality that states that r equals to 7 plus minus root of 49 plus 1800 over 4. 49 plus 1800 is 1849, so I write it down. We'll get that r equals to 7 plus minus root of 1849 over 4. So r equals to 7 plus minus root of 1849 is 43 over 4. So r equals to 7 plus minus 43 over 4. So here we have two solutions for r. The first solution is that r equals to 7 plus 43 over 4. 7 plus 43 is 50, and 50 over 4 is 12.5. So we found out that r equals to 12.5 units. Okay, so r equals to 12.5 units, but we have the other solution also, that r equals to 7 minus 43 over 4. 7 minus 43 is minus 36. Minus 36 over 4 is minus 9. R equals to minus 9. The second solution for r is that r equals to minus 9, but because of the fact that r is the radius of the semicircle, it must be a positive number, so r equals to minus 9 is not correct answer, so we cancel this possibility, and we left only with the solution that r equals to 12.5 units. So the diameter of the semicircle, that is AB, it equals to 2 times the radius. 2 times the radius is 2 times 12.5. 2 times 12.5 is 25. So the diameter of the semicircle, that is AB, equals to 25 units, okay? The diameter of the semicircle equals to 25 units. Okay, so now the diameter of this semicircle equals to 25 units. AB equals to 2 times the radius equals to 25 units. Okay, so that is the solution to the question. Now I'll summarize the lecture. So actually we wanted to find out the diameter of this semicircle, and we know that AB is the diameter of this semicircle, but we want to find out the size of AB, the value of AB. We also know that chord AD equals to 7 units, chord DC equals to 15 units, and chord CB equals also to 15 units, and we want to find out the size of AB, or the value of the diameter of this semicircle. So in the first step we made a construction. We joined together points D and B by a straight line, and actually peripheral angle was created. The peripheral angle ADB was created, and according to rule number 1, the size of angle ADB is 90 degrees. It is a right angle. Rule number 1 states that peripheral angle resting on the diameter of the circle is equal to 90 degrees. Okay, so this peripheral angle ADB, rests on the diameter of this semicircle that is AB. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Okay, so in the next step, we define the center of the semicircle as point O, and then we connected together points O and C by a straight line, and we also connected together points O and D by a straight line, and then we related to triangles, the green triangle, triangle ODC, and the orange triangle, triangle OCB. On those two triangles, DC, side DC of the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units. DC equals to CB equals to 15 units. And also DO equals to BO. Both of those two sides are equal to the radius of the semicircle. And also OC equals to OC. It is a common side. It belongs both to the green triangle and also to the orange triangle. It is a common side. So we actually proved that the green triangle, triangle DOC, is congruent to the orange triangle, triangle COB, according to side rule. When you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles are congruent to each other according to side rule. Okay, then for the fact that those two triangles congruent to each other, those two angles are also equal to each other according to the rule that states that corresponding angles in congruent triangles are equal to each other. Okay, so angle OCD equals to angle OCB, and if we define this angle as alpha, then this angle will be also equal to alpha. Then we focus on triangle DCB. On triangle DCB, DC equals to CB. Both of those two sides are equal to 15 units. And we have rule number 2 that states that in front of equal sides in the triangle, there are equal angles. Okay, so actually we have in triangle DCB two equal angles, two equal sides, and in front of this side we have angle EDC, and in front of this side we have angle EBC. And according to rule number 2, those two sides that are located in front of equal sides are also equal between them. So those two angles are equal between them, and if we define one angle as theta, then the other angle will be also equal to theta. Okay, so angle BDC equals to angle DBC equals to theta, and then we focused on the green triangle, triangle DEC, and the orange triangle, triangle BEC. On those two triangles, angle DC equals to angle CB. Both of those two angles are equal to 15 units. This equals to CB equals to 15. And those two angles are also equal to each other. And also EC equals to EC. EC, side EC is the common side. It belongs both to the green triangle and also it belongs to the orange triangle. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we proved that the green triangle is congruent to the orange triangle according to side angle side rule. Those two triangles are congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that those two angles are also equal to each other. And if we define one angle as x, then the other angle will be also equal to x. Okay, then we know that BD is a straight line because we connected together points B and D by a straight line, so BD is a straight line. And we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so the sum of the angles at this point on a straight line equals to 180 degrees according to rule number 3. So angle DEB, this angle must be equal to 180 degrees according to rule number 3 from one side. Again, angle DEB must be equal to 180 degrees according to rule number 3 from one side, but angle DEB will be equal to this angle plus this angle, that is actually x plus x, that is 2x, so angle DEB also must be equal to 2x. And from this equality, we can derive that 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees. So angle x equals to 90 degrees. So this is a right angle, and this angle, that is angle x, is also a right angle because angle x equals to 90 degrees. And then we focused on OC. OC is a straight line because we connected together points O and C by a straight line. So OC is a straight line. And if we look on the straight line OC on the left side, we know that the sum of the angles along a straight line is equal to 180 degrees. So if we focus on point E, 90 degrees plus this angle, that is angle OEB, must be equal to 180 degrees according to rule number 3. Again, 90 degrees plus the size angle OEB must be equal to 180 degrees according to rule number 3 because of the fact that the sum of the angles on a straight line is 180 degrees. So 90 degrees plus the size of this angle must be equal to 180 degrees. Okay, and if we subtract 90 degrees from this equality, we will get that angle OEB equals to 90 degrees. So this angle OEB, is a right angle. So we actually found out that around point E we have 3 right angles. This angle, this angle, and this angle are right angles. And the sum of those 2 right angles is 90 degrees times 3 is 270 degrees. Okay? And we defined angle OED as y. And we have rule number 4 that states that the sum of the angles around the point is equal to 360 degrees. And especially the sum of the angles around point E must be equal to 360 degrees according to rule number 4. So we have 3 angles that the sum of them is 270 degrees plus angle, this angle, that is angle y, must be equal to 360 degrees according to rule number 4. Okay, so the sum of the three angles around point E, that is 270 degrees, it is 270 degrees plus the size of angle Y, must be equal to 360 degrees according to rule number 4. So here we can subtract 270 degrees from this equality and we get that angle Y equals to 90 degrees. Okay, so the size of this angle is 90 degrees, so we found out that all the angles around point E are right angles. Okay, and then we focused on the right triangle, triangle ADB, and the right triangle, triangle OEB. Triangle ADB is right triangle because this angle is right angle, and triangle OEB is right angle because this angle is right angle. So I do these two triangles again, and we know that those two angles are equal to each other because they are equal both to 90 degrees. And also we have angle B that is a common angle. It belongs both to the small triangle, triangle OEB, and also to the big triangle, triangle ADB. So it's a common angle. We can write down that angle B equals to angle B. And then the third pair of angles, those angles are also equal to each other according to third angle theorem. Third angle theorem says that if you have two triangles that are equal between them in two angles, then the third pair of angles must be also equal between those two triangles according to third angle theorem because it is complementary to 180 degrees. So we actually proved that all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle OEB. Therefore, those two triangles are similar to each other, and from this similarity, we have the following relationship between the sides of those two similar triangles. The relationship is OB over AB equals to OE over AD. OB over AB equals to OE over AD. Okay, and we know that OB equals to R, AB is the diameter, it equals to 2R. So OB equals to R, AB equals to 2R, and AD equals to 7 units. Okay, R is cancelled here, and we found out that OE equals to 7 over 2 units, and then EC equals to OC minus OE, and OC is the radius of this semicircle, and OE equals to 7 over 2. So EC equals to R minus 7 over 2. Then we know that those two triangles are right triangles, and we created the equality that states that EB square equals to EB square, and then we implemented the Pythagorean theorem on those two right triangles, and EB square in relation to this triangle equals to OB square minus OE square, OB square minus OE square, and EB square in relation to this triangle is equal to CB square minus EC square. Again, EB square equals to CB square minus EC square. We know that OB equals to R, OE equals to 7 over 2, so OE square equals to 49 over 4, CB equals to 15 units, so CB square is 15 squares, 15 square is 225. EC equals to r minus 7 over 2, so EC square is r minus 7 over 2 square. So we solve this equality and we got to the quadratic equation that 2r square minus 7r minus 225 equals to 0. Then we have this general formula for quadratic equation when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we can find out the value of x according to this special formula. So in our quadratic equation, the variable x is equals to r, and a equals to 2, b equals to minus 7, and c equals to minus 224, so the only minus 225. The only thing that is left to do is to substitute the variables in the quadratic equation by the values that we found for those two coefficients and x. We did it and we found that the radius of the semicircle equals to 12.5 units, and we have also the second solution that the radius of this semicircle equals to minus 9, but it is impossible that the radius will be a negative number. Therefore we cancel this possibility and we left only with the possibility that the radius of the semicircle equals to 12.5 units, so the diameter that equals to AB is 2 times the radius. 2 times the radius is 2 times 12.5 units. So we found out that the diameter of the semicircle equals to 2 times 12.5, that is 25 units. Okay, so the final answer to the question is that the diameter of this semicircle, that is actually AB and that is actually 2 times the radius of the semicircle, equals to 25 units. Okay, thank you very much.